Hi everyone! In this video, we will learn about subtopic 3.1 Inequalities. The objective of this lesson is to solve linear inequalities by expressing the answer in interval or set form. Inequality signs. I have four types of inequality signs, and they are greater than or equal to, less than or equal to. Types of inequalities. We have three types of inequalities: linear inequalities, quadratic inequalities, and lastly, rational inequalities. In this video, we will talk about linear inequalities. In this slide, we will talk about examples of linear inequalities. I've listed down 4 examples. All of these 4 examples are linear inequalities because, first of all, look at the symbol. As long as we have any of these 4 symbols, it is an inequality. Next, they are linear because this time we're going to look at a variable x, j, and r. All of these variables have the power 1. So any inequality with variable to the power 1 is a linear inequality. Okay, we look at some examples. This is example number 1. I will explain this note later. We look at the question first. Now my question is 3x greater than 27. I want to solve for x, meaning that I only want x, but 3 is disturbing me. 3 is in front, it is disturbing me. So what can I do? So from the note here, in solving linear inequalities, we divide or multiply both expressions on the left-hand side and also the right-hand side. So we have to be fair. We have to consider both the left and both the right. And then another condition, we can choose to divide or multiply with the same positive number. Okay, the number must be the same and the number must also be positive. Because if we do it with a negative number, then our symbol of inequality is going to change. So I can go back to my example. Now what I'm going to do next is I'll divide everything with 3 on the left and also on the right. So finally, I come to this solution that is x greater than 9. However, previously we've learned how to write our answer. We have learned to write it in solution set and also interval notation. So we will now try to express x greater than 9 in solution set. So first of all, for solution set, I need curly brackets. Okay, I have the curly brackets there. Then I need my variable. The variable here is x. So I have x, then double dot. I copy the solution just now. So that is my solution set. Now for interval notation, I can look at my solution set. If we can't figure the interval notation out, I can draw a number line first. The number here is 9, so I have a point at 9. And the point here is an open point because the symbol for inequality at 9 is greater than, so there is no equality, so it will be an open point. Numbers that are greater will move towards the right-hand side. So from the number line, I know that the numbers will be greater than 9. It will continue to go to the right, so it will get bigger and bigger. How big will it be? It will get bigger until it approaches positive infinity. So now, interval notation, I need 2 numbers. Smaller number that's on the left, so I have 9. So 9 is on the left, and then the number gets bigger, approaching infinity. The bracket at 9 is open because it is an open point. And infinity is always an open bracket. Now for example 2, I have this question, negative 3x greater than 27. So I want to solve for x. I'm only interested in x, but negative 3 is disturbing me in front. So what I can do is I can divide both the left-hand side and right-hand side with negative 3. So since I'm dividing it with a negative number, it will be a special case because what's going to happen now? back to my notes here. If you multiply or divide by a negative number, this will reverse the direction of the inequality. So now, continuing my question, I divide the left-hand side and the right-hand side with a negative number here. My direction will be reversed. In the first line, the symbol used is greater than. And in the next line, after I divide it with a negative number, the direction is reversed. From greater than, it now becomes less than. Okay, so we have to be very careful when we want to multiply or divide an inequality with a negative number. So solving it, I get x less than negative 9. I can further write the answer in solution set or interval notation. For solution set, I need curly bracket. The variable is x, so I have x double dot, and I copy the inequality just now. For interval notation, I can draw my number line. At the number negative 9, I have a point. The point here is an open point because the symbol used is less than. So there is no equality sign, so the point is open and it moves to the left. It moves to the left because the inequality is smaller than. So it means that all the numbers moving to the left-hand side will be smaller. How small will this number be? This number will be small until it approaches negative infinity. So for my interval notation, I have negative infinity to negative 9. And the bracket at negative 9 is open bracket because negative 9 is an open point. Now for example 3, solve the following linear inequalities. The question is 2x minus 12 less than or equals to 4. Here I'm only interested in 2x. I'm only interested in the one with x. So negative 12 is disturbing me. I can bring it to the right hand side. When I bring it to the right hand side, negative 12 now becomes positive 12. So I have 2x less than or equals to 16. This time I only want x. What I can do to 2 is I can divide 2 at both the left hand side and the right hand side. Over here, take note that I'm dividing both the left hand side and right hand side with a positive number. So the inequality still stays the same. So finally, I have x less than or equals to 8. I can write this in solution set. I have my curly bracket, the variable is x, and then double dot, and I copy back the inequality x less than or equal to 8. For interval notation, if I can't figure it out, I can straight away draw it. Here I have the number 8, and at 8 the point is a closed point. It is a closed point because of the symbol. The symbol has an equality, and it moves to the left hand side because it's getting smaller. The number will get smaller and smaller until it approaches negative infinity. So interval notation, smaller number on the left, larger number on the right. It is from negative infinity to 8. And the bracket at 8 is a closed bracket because the point is a closed point. Just now we look at linear inequalities. Now we will look at combined inequalities. And these inequalities are still linear. So this is my question. Over here I have 2 inequalities. So this is the meaning of combined inequalities. And they are in the form of smaller than, because smaller number is always on the left, larger number is always on the right. I'm interested in negative 3x, but 5 is disturbing me, so I can send 5 to the left hand side and also 5 to the right hand side. Sending 5 to the left and right means that I'm going to minus 5. So I get negative 15 less than or equals to negative 3x less than negative 3. Now I'm only interested in x, but negative 3 is disturbing me, so I can divide everything with negative 3. What happens when we divide with a negative number? Recall the special case just now. When I divide with a negative number, the sign will be reversed. So just now, I have the sign to be less than or equals to. Now, when I divide with a negative number, it is changed to become greater than or equal to. And over here at the other end, just now it was less than. And after I divide with a negative number, the sign now is reversed to become greater than. So solving it, I now get 5 greater or equals to x greater than 1. This is not a nice way of writing inequality because smaller number will always be on the left and big number will always be on the right. So this means that I have to reverse this inequality. So I do backwards. I get 1 smaller than x, smaller or equals to 5. This is a nice way, this is the correct way of writing combined inequalities. Smaller number on the left, big number on the right. I can now write this in interval notation, two numbers 1 and 5. The bracket at 1 is open because the inequality here is smaller than, no equal sign, so it is an open bracket. At 5, it is a closed bracket because there is an equality symbol. Or what I can do is, I can also draw my number line, two numbers, 1 and 5. At 1, it is an open point because there is no equal sign. At 5, it is a closed point because there is an equality. So combine these 2 points, the interval notation will give me 1, 5, open bracket at 1, close bracket at 5. And finally, solution set, I have my curly bracket, my variable is x, then double dot, and I copy back this correct way of writing the inequality. Next, for example 2, I have 7 less than or equal to 2 minus 2x less than 8. Here, I'm only interested in the one with x, so I'm only interested in negative 2x. So what I can do to 2 is, I can move it to the left and also move it to the right. When I move it to the left and right, it now becomes negative 2. So solving it, I get 5 less than or equals to negative 2x less than 6. So this time, I'm only interested in x. So what I can do to 2 is, I can divide negative 2 at both sides. Dividing everything with negative 2 means that I'm dividing with a negative number. So see what happened to the sign this time. Just now the sign is less than or equals to. After dividing with the negative 2, my sign is now reversed to become greater than or equal to. And at the other side, just now it was less than. After dividing with a negative number, it becomes greater than. Okay, the sign is changed. And now I get negative 5 over 2 greater or equals to x greater than negative 3. But this is not the correct way of writing inequality because smaller numbers must be on the left, bigger number on the right. So I do it backwards. And this is the correct way of writing. I can now write this as interval notation. If you don't know how to write it straight away, you can draw a number line first. Two numbers, negative 3 is smaller than negative 5 over 2. Now the points are open here because the inequality here is less than. And at negative 5 over 2, it is less than or equals to. So I have a closed point because I will now include that number. Combine these 2 points. And you just see the points, then we can already figure out the bracket. Negative 3 open point. So I have open bracket. Negative 5 over 2 close point. So I have close bracket. So that is for interval notation. And finally, solution set. I have curly bracket. My variable is x. And last step, I just copy the inequality. Negative 3 less than x less than or equals to negative 5 over 2. Over here in this slide, there are 4 questions for you to try. Apply what you have learned just now. Solve the inequalities, give your answers in interval notation and solution set. You may pause this video while trying the questions. Here are the answers to the question just now. I hope all of you are able to understand and answer the full questions. We have now come to the end of the video. Thank you very much for listening, and I hope all of you have a great day.